All right, so we've looked at the triangle sum theorem, we've looked at the quadrilateral sum theorem, and now we're going to generalize this with the polygon sum theorem. And that says that the sum of the measures of the angles of a convex n-gon, doesn't matter how many sides there are, it could be 7, 8, 10, 12, 40, doesn't matter how many sides there are. How many other sides there are, we're going to take that value, subtract 2 from it, and then multiply it by 180, and that will give us the amount of degrees in that n-gon. I have 4 pictures up on the screen here to kind of illustrate this a little bit. So let's say we have a 5-gon, also called a pentagon. We can generalize any polygon and just how many ever sides it has, and say it's an n-gon, 5-gon, 6-gon, 7-gon, 8-gon, so on and so forth. So 5-gon pentagon, because it has 5 sides. You'll notice that I've taken this pentagon and I've separated it into triangles. So I've gone from a vertex and I've drawn the diagonals from that vertex. From this point here to this point here is called a diagonal. Might not be what we are familiar with diagonal meaning, but that's a diagonal. When you go from a vertex to another vertex that's not connected by a side. So I have A to here and then A to this vertex, creating another diagonal, and I've created here 3 triangles. And in each of these triangles there are 180 degrees. So I'm going to take 180 plus 180 plus 180, in other words 180 times 3, and I'm going to get 540 degrees. That's how many degrees are in a pentagon. Any pentagon, doesn't matter, there will always be 540, because you can separate a pentagon into 3 triangles coming from one vertex. Now notice, I'm not going from here over to here. I'm not going to draw that diagonal too, because if I do that, yeah, I'm going to get a whole bunch of other triangles, but then I'm going to create angles within the polygon that are not from the outside angles of the polygon. So I always pick one vertex and then draw the diagonals from that vertex. So, and this follows along lines of our polygon sum theorem formula here. N is the number of sides, so we have 5. We're going to subtract 2 from that. 5 minus 2 is 3, and then multiply that by 180, and we get 540. So there are 540 degrees in any pentagon. With a 6-gon, also known as a hexagon, I'm going to separate that into triangles from any given vertex. Pick this one, draw that diagonal, this diagonal, and that diagonal. You'll notice there are 4 triangles that are formed, and in each of those triangles there are 180 degrees. So I'm going to do 180 times 4, and that gives us 720. What that means is that any hexagon has 720 degrees, is made up from the interior angles. A 7-gon, also known as a heptagon, can be separated into 1, 2, 3, 4, 5 triangles. And again, that makes sense because we have the number of sides. Minus 2 is 5. Multiply 5 by the 180, which is how many degrees are in each of these triangles, and we get 900. So any heptagon has 900 degrees when you take the interior angles and add them up. And then an 8-gon, also known as an octagon. That can be separated into 1, 2, 3, 4, 5, 6 triangles, 180 degrees per triangle. We're going to get 1,080 degrees. That's what the interior angles of an octagon add up to, and this can be generalized to any polygon. Doesn't matter how many sides there are. If there's 13, you can do 13 minus 2 is 11. 11 times 180, not sure what that is at the top of my head. That's how many degrees would be in a 13-gon, so on and so forth.